Welcome to the Matrix, section 8.2.1, the Matrix. Today we're going to look at some of the basics of a matrix and the easiest operations, which is matrix addition and subtraction and then the scalar multiplication. So what is a matrix besides a movie from the 90s? A matrix is a rectangular array of numbers or algebraic expressions enclosed in square brackets. So here are two examples of algebraic expressions. Rectangular meaning you have full rows and columns. The rows and columns are full. These are all numbers and they're enclosed in square brackets. Here, enclosed in square brackets, again it's a full row and the columns are full as well. And this is a number, but these are algebraic expressions. Non-examples, Matt, Carol, Lindsay, they are names, not algebraic expressions. And then this one, this is not a rectangular array of numbers because you're missing numbers here and here. All right, we're going to be using dimensions a lot when we do matrices. So the dimensions of a matrix are given as rows by columns. In the examples above, the first one, so this is a two rows, two columns matrix, so we call this a 2 by 2. In the second, it is a 1 row by 3 columns, so it's a 1 by 3. So next it says state the dimensions for each of the matrices. So pause and try to do those. All right, so this is 3 rows and 1 column, so this is a 3 by 1. This is 2 rows and 3 columns, so 2 by 3. This is 3 rows by 2 columns, and this is 3 rows by 3 columns. All right, we can also do operations with matrices. So the first thing we're going to look at is adding and subtracting matrices. So the way you add or subtract matrices is you add or subtract corresponding elements of the matrix. And in order to do matrix addition or subtraction, the dimensions must be equal. So if we look at our first example, we can add these two matrices together because they're both 2 by 3 matrices. And what we mean by adding or subtracting the corresponding elements means that in the number in row 1, column 1, I'm adding to row 1, column 1. So I'm adding 1 plus 0. So my answer for row 1, column 1 is 1. 1 plus 0 is 1. Then I'm adding row 1, column 2 to row 1, column 2. So 3 plus 3 is 6. I'm adding row 1, column 3 to row 1, column 3, negative 2 plus 2 is 0. Row 2, column 1 plus row 2, column 1, 9 plus 18 is 9 plus 8 is 17. Row 2, column 2 plus row 2, column 2, 4 minus 3 is 1. And then row 2, column 3 plus row 2, column 3, 2 plus 1 is 3. So that is my final answer matrix. I can also subtract matrices. So again, they have to have the same dimensions, which these do. So I'm going to take 18 minus 12, which is 6. Just be careful. Negative 4 minus 2 would be negative 6. And here's where you have to be careful. 2 minus a negative 1. This would be a double negative, so I'd be adding. 2 plus 1 is 3. 0 minus 9 is negative 9. 5 minus a negative 6, and that double negative would be adding, so 5 plus 6 is 11. And then negative 7 minus 0 is negative 7. So that's adding, subtracting matrices. Scalar multiplication is the last operation we're going to be looking at to start. This allows you to scale or resize elements of the matrix, and the way you do it, each element is multiplied by the scalar. So it's almost like the distributive property. if you want to think of it that way. So here we have 4 different matrices. Matrices are always given by capital letters, just so you know, they're labeled with capital letters. So this is matrix A, matrix B, matrix C, matrix D. And this one says evaluate the following. So this one I'm going to take 2. This is scalar multiplication, 2 times every number in matrix A. So I'd write this as 2 times 4, negative 5, 9. And then I am just taking every element in matrix A and multiplying it by 2. So my final answer would be 8, negative 10, and 18. Here I'm taking every element and multiplying it by negative 3. So negative 3 times matrix B, which is 0, 12, 3, negative 9. So negative 3 times 0 is still 0. Negative 3 times 12 is negative 36. Negative 3 times 3 is negative 9. And negative 3 times negative 9 is positive 27. You can do 4C on your own here. 3A plus D. So now I'm doing some scalar multiplication with some addition. So 3A would be saying 3 times matrix A, 4, negative 5, 9, plus matrix D, negative 2, 4, 7. So you have to follow PEMDAS, just like your usual. So I would multiply before I add or subtract. So I'm doing the scalar multiplication first. 12, negative 15, and 27. And now I do have the same dimensions, so I can add the 2 matrices together. 12 minus 2 is 10. Negative 15 plus 4 is negative 11. And then 27 plus 7 is 34. So that's our final matrix. Let's just do one more. We'll do negative 2b minus 3d. So negative 2b would be negative 2 times matrix B. 0, 12, 3, negative 9. Minus 3 times matrix D. Now you may say to yourself here, well, these don't have the same dimensions. I can't do that. Well, yeah, eventually you're not going to be able to add or subtract them. But what you can do is you can do the scalar multiplication first. And you must do the scalar multiplication first. So I'm going to take the first matrix B, multiply everything by negative 2. So I still have 0, negative 24, negative 6, 18. And then you have an option here. You can either distribute by positive 3 and then keep this as subtraction, or you can multiply it by negative 3 and then make the problem addition. So I like to just kind of multiply everything by negative 3 and then add the matrices. That's the way I do it. You're not wrong if you do it the other way, though. So I'm going to do negative 3 times negative 2 is positive 6. Negative 3 times 4 is negative 12. And then negative 3 times 7 is negative 21. And now it's asking me to add those matrices together, but since they are not the same dimension, I actually can't do that. So I'll just stop here. All right, try these 2 on your own, and welcome to the matrix.